Hello. Today I'd like to talk about absolute value equations. And to do that, let's start looking at the idea of the definition right here. Absolute value is a distance of number from 0 on a number line. So we look at this. If you have the absolute value, let's try the absolute value of 5. If you look at that, 5, if this is 0, plus 5 is here, so the distance I've traveled is actually 5. Or if I have minus 2, for example, well, minus 2 is over here, right? How far I travel to get there? Do we do distance in negatives? You never heard someone say, I'm going minus 2 miles, right? We don't do that. So distance is always positive. So the absolute value of minus 2 means travel from 0 to minus 2. I covered a distance of positive 2. So we want to use that idea to solve the absolute value of x equals 5. What we're saying here is the distance of x from 0 on the number line, so look at it this way, here is 0. X is exactly 5 units from 0. And I can travel left or I can travel right. So if I travel right, from 0 I go 5 units, it puts me at positive 5. So x can equal 5. Or if I travel left, I'm going to go this way, a distance of positive 5, which puts me at position of minus 5. So for a simple one, we solved it. Either it's plus 5 or it's minus 5. It turns out it doesn't matter what this value right here is, the x right there inside. It could be easy like x, it could be more complicated, and most ones we're going to do are a little more complicated than that. It's always going to be the same. It's going to be the inside equals the positive outside value here, and the inside equals the negative value. So our rule, so again, wherever I see the inside, it's just the inside. Doesn't matter what it is. The inside, in this case u, will either equal plus c, because it traveled right up here on the 5. Absolute value of x equals 5, it either traveled a distance of positive 5 to the right, or it went to negative 5 to the left, which is still a distance. So the inside either equals positive c, or the inside equals negative c, because I can either go left or right from 0. All right, let's do a little, do one here. So we do it again. All we're saying is this inside will either equal, it'll be positive 7 or it'll equal a negative sign. So just take the inside, doesn't matter what it is. So 2x minus 5 here, 2x minus 5 here. And we're going to solve these two equations simultaneously. So plus 5 equals 12, right? Again, recall, right? 2 times x, because it's multiplication holding the 2 and x together, to break, I do the opposite of multiplication, which is division. So divide by 2, divide by 2. X equals 6. Do the same thing on the right side. Add 5. Add 5. 2x equals minus 2. Divide by 2's. X equals minus 1. Now, sometimes they may ask you for a solution set. A solution set is pretty simple. You can take your two numbers, minus 1 and 6. The order actually doesn't make a difference. That said, select a small one first, and you can put these braces around it. So if they're asking for a solution set, this would be the answer. Okay, let's take a look at this one. Sometimes you're going to have an absolute value and the absolute value equal to each other. It behaves just the same as before, so we're going to treat it just like this, right? If u equal absolute value equals c, then u equals plus c, or u equals minus c. So we'll just call this guy right here the x minus 1. X minus 1 equals, or x minus 1 equals. And then we'll take the positive version of x plus 6. So the positive version of x plus 6 is no changes. The negative version, which is minus all the x plus 6. And I could go into more detail about why that works. It just turns out that it gets a little bit complicated. The easiest way to think about it is it just kind of behaves that same rule. So if someone wants to actually hear about the why, I'm more than willing to sit down and do it with you, but most people don't want to see that. It gets kind of big and messy. So now all we do is just to solve it. So we get minus x and minus x. And this one gets a little weird because we end up with 0 minus 1 equals 0 plus 6. So in this case, this particular version has no solution. So one case doesn't work. That's okay, it happens. You should not see it happening in any of your stuff. It's kind of a weird one, it's made up on the fly. But it does happen. More likely than not, you should get an answer for the left side and answer for the right side. The right side, it actually does have an answer here. So if I solve this, x minus 1 equals minus 6 plus x, not plus, sorry, minus x. And if you solve it, plus x, 2x minus 1 equals minus 6. Add 1 to both sides. You get 2x equals minus 5. Divide both sides by 2. Kitty, you're in the way. Get minus 5 halves is your answer. So again, on problems like this with absolute value equals absolute value, I just chose one at random. It came out that one side works and one side doesn't. The problems you're going to get, both sides should give you answers. In this case, minus 1 does not equal 6. That's never true, so it's a null set or empty set with no solution. You can write no solution if you like. Or in the end, it just has one solution. And the final problem from this section I want to look at is the absolute value of 2x plus 1 equals minus 12. And this was kind of a, some people call it a trick question. It's actually possible to answer this question without doing any work. The thing you got to remember is absolute value is always positive. So this side right over here is positive. The right side is negative. Are there any positive or negative numbers? Is it a positive number or a negative number that equals to each other? Nope. So this isn't true. So this is no solution. Or you use the symbol of the empty set symbol. Now, the problem with this problem here is, or the issue is, this problem is you can do the work. You can say 2x plus 1 equals minus 12, or 2x plus 1 equals plus 12. You can do the work here, you'll get answers. The answers will be wrong. So you just need to pay attention. This is not something that I'd ask on an exam or anything, but it does kind of show up in the homework once in a while. It's nice to see a little trick. So let me know if you have any questions about absolute values. I think that's all I want to say for this right here.